Hey guys, and welcome to another video. Today we're going to be walking through introducing differentiation. So again, it's an AS topic, particularly this video. We're not going to be covering any kind of A-level differentiation, so no differentiating the trig functions, nothing to do with exponentials, and nothing to do with like chain rule, quotient rule, or the product rule. So should be quite a nice video. Like I said, more of an introduction if you've just been covering the basics of differentiation and you were looking at some kind of easier exam questions. This video will be perfect. Okay, so let's jump straight into this and see what we've got. So the first question from exercise 12c, question 4, we're given that 2y squared minus x cubed is equal to 0, where y is positive. So we're just asked to find dy by dx. So to find dy by dx, the issue with this question is normally we need it in the form y equals, right? So y equals something that we can differentiate in terms of x. At this point here, will it mean 2y squared minus x cubed being equal to 0? We can't quite work with this at the moment. So to get it into this form, we've just got to rearrange, right? So 2y squared is equal to x cubed, and x cubed to both sides. Here now, to get it into y squared, I divide by 2, so y squared x cubed over 2. Or you could write that as a half x cubed. And then finally, to get this here, we just square root, right? So let's rewrite that as well. That's a half x cubed. So then finally, y, and this is the important part because y is positive, we're only going to take the positive square root, right? So this will be the square root, so it'd be 1 over, so if you square root a half, that'd just be 1 over the square root of 2. So that's 1 over root 2 times by x to the 3 over 2. Okay, so if you've got x cubed and you square root it, that'd be the same as x to the 3 over 2. So that's x to the 3 over 2. And then from here, this is where we now differentiate. Okay, so we've done all the legwork to get to this point. Now we just differentiate. So dy by dx. Okay, so times your constant here, 1 over root 2, by this power. So that'll give us 3 over 2 root 2. So 1 over root 2 times 3 over 2, 3 over 2 root 2. We'd have x, and then subtract 1 off your power. So if you've got 3 over 2, and you minus 1, that's the same as 3 over 2 minus 2 over 2, which would just give you a half, right? So that'll be x to the power of a half. And that's simply just your answer, okay? So you can write that as 3 over 2 root 2 square root of x if you really want to, but this form here is absolutely fine. Okay, so just a 2 marker to get started, but it's very important we get it into this form here. Okay, so before you can differentiate, we need it in that form. So that's the first question done. Let's take a look at the next one. So again from the textbook, we've got mixed exercise 12 question 4. So we're given an equation, so y is equal to 7x squared minus x cubed. And it asks us to calculate the x coordinates of the points on the curve with the equation, or with this equation at which the gradient is equal to 16. So when the gradient is equal to a value, remember that gradient is given by our differential here, dy by dx. So in this case, we need to differentiate and set it equal to 16. So let's do that. So differentiate this. Should be a nice, easy function to differentiate. So 7 times 2 would be 14. Take 1 from the power, so it'd be x to the 1, or just x. That's a 1 in front of the x, so minus 1 times 3, so that'd be minus 3. X, take 1 from the power, so minus 3x squared. So that's dy by dx. Now remember we just said if the gradient is equal to 16, then that means dy by dx is equal to 16. So 14x minus 3x squared is equal to 16. So notice here we've actually got a quadratic, and it's kind of the big clue in the fact that we're going to get points, right? The x coordinates of the points. So what we should get is a quadratic which we can factorise or solve, and we'll get 2 solutions. So I'm going to take my 3x squared onto this side just to make it positive, just to make life a bit easier. So that'll be positive 3x squared. Subtract 14x off both sides, minus 14x plus 16. Okay, and at this point here, just check if you can factorize it, and what you will find out is that it does factorize. That'll be 3x. So I'm just going to write my brackets first. So I always kind of write it like that, and then if I need to change one to a plus, I can do that later on. But just factorising this, what you'll get is 3x minus 8, and then x minus 2. Okay, and this is actually equal to 0, which means this is equal to 0. So at this point now we can work out the x values, so the x coordinates. So that means 3x minus 8 is equal to 0, which means 3x is equal to 8, which means x is equal to 8 over 3. And then similarly, with this one here, x minus 2 is equal to 0. That means x would be equal to 2. And that's it. So 4 marks for that. You know, just setting up your differential. Be very aware of this fact. So if you've got a green that's equal to a value, we differentiate and then set it equal to that value. Okay, so that's that question done. Hopefully nice and easy. The next one again from the mixed exercise, quite a short one. We've got a function f defined by f of x. So that's x plus 9 over x. Now this is quite common, and what I'd always do is if you see something like this here, this 9 over x, I'd write it in index form. So what I mean by that is, remember the fact that 9 over x, that's equal to 9x to the minus 1, like that. Because this is much easier to differentiate than trying to differentiate this on the spot. With enough practice, you'll be able to do this on the spot, but while you're learning it, or even just for your exams, don't risk it, guys. Just write it like that, okay? So what we need to do is find f prime of x. So remember, f prime of x, that's just the same as dy by dx. So dy by dx is equal to f prime of x. So if you find f prime now, that's the same as differentiating. So the differential of x would just be 1. 9 over x, remember we've wrote that as 9x to the minus 1. So 9 times minus 1, so that'd be minus 9. Subtract 1 off the power, so minus 1 minus 1. So that gives us minus 2. Okay, and you can actually rewrite this if you really want. That'd be 1 minus 9 over x squared. Okay, and we will kind of need that form for part B. So that's f prime of x there. So then part B, so that's part A, we have to solve this. So solve f prime of x is equal to 0. So if we set this equal to 0, so 1 minus 9 over x squared is equal to 0. So what I'm going to do is I'm going to take this negative part across to make it positive. So 9 over x squared is equal to 1. Now we want to solve for x here, so multiply through by x squared. So I'm going to get 1 times x squared, which is just x squared. So x squared will be equal to 9. And then, seeing as we have no restrictions here about what x, whether x is just strictly positive, because there's no restrictions, we're going to take both solutions here. So therefore, x will be equal to plus 1 minus 3 there. Okay, so it's not just plus 3, we can include then the minus 3 as well. So yeah, another nice easy one there. Hopefully that's all nice and clear. So let's check the next one. This time from the review exercise. So we've got two parts to it. We're given an equation, y equals 3x squared plus 4 root x. And we have to find dy by dx and then the second derivative here for 2 marks. So let's do part A first. So we write the function 3x squared. And again, we've got this 4 root x right in index form. Make life easier for yourself. So this 4 root x, remember the root x, that's the same as 4x to the half, because that's root x. So that's going to be 3x squared plus 4x to the half, like that. So finding dy by dx now, if we differentiate this, well, 3 times 2 is 6, take 1 off the power, so that's just 6x to the 1. I should have wrote dy by dx. So dy by dx. Make sure yours isn't quite as crammed as mine on your exams. So 6x, and then 4 times a half, so that'll just divide 4 by 2, so that'll be 2, plus 2x, and then subtract 1 off your power. So a half minus 1, that's the same as minus a half, like that. Okay, and then part B, so I wouldn't bother rewriting this 2x to the minus a half here, because we've got to differentiate it again. And remember, the second derivative here, we calculate the second derivative using the first derivative. So with the first derivative now, differentiate this once more. So 6x, derivative of that, will just give us 6. 2x to the minus a half, so divide 2 by 2, so that'd be 1, but because it's minus a half here, that would be minus 1. That's going to be minus x. Subtract 1 off a half, or, yeah, subtract 1 off a half, so minus a half, minus 1, so that'd be minus 2 over 2, which will give you minus 3 over 2. So minus x to the minus 3 over 2. Okay, so there's nothing more to that question, we're just finding the second derivative there, so hopefully that's nice and easy. So the next two questions now, these are two questions that have been taken from the old exam specification. So this was from C1, which was one of the AS exams. So this is question 7 from June 2010, if you want to check that out yourself. And you're given y here. So ax cubed minus 4 root x, so again, we've literally just done that one, that's 4x to the half. And we've got this little tricky bit here, we've got 3x squared plus 2 over x. So we want to differentiate this, but how do we deal with this? Now one technique you'll learn later on when you're doing differentiation is something called a quotient rule. So because it's a quotient, you could apply a quotient rule to it, but it's much easier than that. And the reason why that's the case is because we're dividing by just this one term here, this x. So what I can actually do is I can split this up into two fractions. So that's 3x squared over x plus 2 over x, okay? Because it's just one term. And because of this case, I can now simplify each one individually. So 3x squared over x, that'll just give us 3x. And then there's 2 over x. Well, we can't simplify that, but we can rewrite that as 2x to the minus 1. Okay. So, with that in mind, let's differentiate this now. So, if we rewrite that again, that's plus 3x plus 2x to the minus 1. So now, this isn't actually anything tricky now to differentiate, we've just got 4 terms, and we've just got to be careful with our powers basically. So, dy by dx, 8 times 3, that'd be 24, subtract 1 off your power, so 24x squared, minus 4 times a half, so that's minus 2x, and just like we did before, if you've got a half and you minus 1, that'd be minus a half. 3x, you differentiate 3x, that'll just give you plus 3, and then finally here, plus 2 times minus 1, so that'd be minus 2x, and then subtract 1 off minus 1, we'll just give you simply minus 2 there. Okay, so believe it or not, that used to be 6 marks. I don't think they're going to be quite that generous anymore, but 6 marks for that used to be quite a nice, easy question. But that's all there is to it. So that's another question done. And then finally, let's have a look at the last one. So question 8 here, 4 parts this question. So we'll take it step by step. So let's take a look at part A first. So we're given this curve C with this equation. So 6 minus 3x minus 4 over x cubed. Now part A asks us to use calculus to show that the curve has a turning point P when x is equal to root 2. Now you see that phrase though, you use calculus, that just means differentiate basically. It could mean integrate, but seeing as we've got a turning point, we have to differentiate to work out that turning point. So if we differentiate this here, this curve, what will that give us? Well, 6, if you differentiate 6, because it's constant, it'll just become 0, so we won't bother with that. Minus 3x, that'll just give us minus 3. And this 4 over x cubed, let's write that in a form we're used to, so that'll be minus 4x to the minus 3 like that. Okay, so differentiating this now, minus 4 times minus 3, that'll be plus 12, and then subtract 1 off your power. So minus 3 minus 1 will be minus 4 like that. But this isn't where the question finishes, because we need to show that the curve has a turning point P when x is equal to root 2. So, remember, the turning point, if you've kind of got like a cubic, for example, so something like this, it's a very bad sketch, but you get the point. If you've got your turning point, you'll have a maximum there, for example, and a minimum there. And these are what we class as turning points. So, same principle here. Remember, the turning point occurs when the gradient is equal to 0. So, applying that here now, I'm going to set this equal to 0. So, set this equal to 0. So, I'll write it on this side actually. So, minus 3 plus 12. I'm going to write this as 12 over x to the 4 is equal to 0. So there's two ways you could do this. You could set this, you could set 12 over x to the 4 equal to 3 and then just solve. Or another way I could do it would be to use x is root 2 and then sub it in there. Both methods are fine. So if you do 12 divided by root 2 to the power of 4, that gives you 3, and then you'd subtract 3. That will give you 0. So that's one way to do it. Or I could, so if we solve that like we're mentioning, that would be 12 over x to the 4. That would be equal to 3. Then we could write that as 3x to the 4, which is equal to 12. Divide both sides by 3, so x to the 4 is equal to 4. And then to solve this, remember, to solve this power of 4 here, that's the same as square rooting and then square rooting again. Okay, so do it over here just so we've got room. Square root it first, so that would give you 2, and then square root it again. So therefore, oops, some of the worst therefore signs ever, x will be equal to root 2. Okay. Now if x is equal to root 2, like we said here, sub that into here, you'll get 0 on both sides. So it does, we can show that that has a turning point P when x is equal to root 2. Part B is a bit of a follow-up from this, so we'll do this just together as well. It says find the x-coordinate of the other turning point Q on the curve. Now use the marks as a guide. This is still quite a common question that they'll ask you. With it being only one mark, you should expect that there's not much work, and really the answer should kind of be jumping out at you. And the reason the answer jumps out at you is due to this part here. When you've got this power of 4, well, we square rooted it, so the square root of 4 is 2. So what I essentially had then was x squared is equal to 2. Well, remember, when we're solving here for x, we obtain two solutions, right? We obtain x equal to root 2, but we also obtain that x is equal to minus root 2. Okay, so we obtain the minus solution as well. So there's a positive solution. This is my minus solution. So that's just my other x coordinate. Okay, so use the marks as a guide. Only one mark, shouldn't be much work. Part C, so if we just quickly rub all this out. So part C is just another one marker, shouldn't be too much work. It just wants us to find the second derivative. So once we go rid of this, let's have a look at it. Can't get rid of it very quick. There we go. So let's have a look. So the second derivative, so it helps. I should have kept the first derivative up. I have written it down. Let's have a check. So what did we get? We got minus 3. So dy by dx was minus 3 plus 12 over x to the 4. But we can write that as 12x to the minus 4. So to find the second derivative now, we just differentiate this here again. So part C, minus 3, differentiate that, it's just a constant, goes to 0, so we won't bother writing that. And then 12x to the minus 4, so 12 times minus 4, that would be minus 48x. Subtract 1 off your power to the minus 5, okay, which is just the same as minus 48 over x to the 5. Now, if you're covering differentiation and you're struggling with this concept of your powers, definitely go back to the first chapter in your textbook and practice. This is something that comes up quite a bit. And it's something you will get used to with practice, so just go back to chapter 1 if you are struggling with that. And then finally for part D, it just says hence or otherwise, state with justification the nature of each of these turning points P and Q. Now, when it says the nature, that just means, is it maximum or a minimum? So, nature, max, or min. So for example, this point here, this would be my max. This point here would be my minimum. So how do we know which one's the max? How do we know which one's the minimum? Well, we use it, and this is why it says hence, using the second derivative. And the way we actually evaluate this is by setting it either, is by substituting the points in, so P and Q. And if the second derivative is greater than 0, that implies that it's a minimum. So that's a minimum. And if it's less than 0, this implies that it's a maximum. So we just need to do that for ours, right? Using this minus 48 over x to the 5. Summing in P and Q, we can work out whether whether it's a max or a min. So for P, which is root 2, sub it into here. So minus 48 divided by root 2 to the 5. Okay, so I've already done this calculation, but if you do it yourself, you should obtain that it's roughly minus 8.48. Now because this is less than 0, that implies that it's a maximum turning point. So that's a maximum. And let's do the same for Q. So if we just do it over here, we should have enough room. So for Q, that's minus root 2. Do it for Q. What we get is minus 48 divided by minus root 2 to the 5. Now because this is a minus to an odd power, this comes out as minus. So a minus divided by a minus will be a positive. And what we get is just a positive of this. It's 8.48, which is greater than 0, which implies that it's a minimum. So therefore, P is the maximum, so that would be P, for example, and that would be Q. Okay, that was just a rough sketch. It might look nothing like that, but just for the general idea, just to give you an idea there. Okay, so that's that question fully done, and that brings us to the end of this video. So I hope it's been helpful. If there's any, if I've made any mistakes, or if there's anything unclear, please leave a comment, guys. So yeah, cheers.